Welcome to the Basic Mathematics. The coordinate geometry. The coordinate geometry. It is a field of mathematics that aids in the presentation of geometric shapes on a two-dimension coordinated plane. The coordinate geometry. Basic coordinate geometry is the study of points, lines and shapes on a coordinated plane. Today, we will discuss and explain in this video location and point coordinates. Cartesian coordinate system, axis of the coordinate system, and quadrants in the coordinated plane. Polar coordinated system and locus. Distance between 2 points, midpoints. Line definition. Line in Cartesian coordinates. Slopes of the line. Perpendicular lines and parallel lines. Perpendicular distance from a point. Line in slope-intercept form. Line in point-slope form. Intersecting point of two lines. Area of a triangle from points coordinate. Loci and Graphs. Line parallel to x-axis or to y-axis. Circle and its equation. We limit our study to Cartesian system. We will find out a formula for a line with two variables x and y, which are the coordinates of a point on the line. In coordinate geometry or analytic geometry, a full use of algebra is made. The coordinate geometry is an amalgamation of geometry, algebra and graphs. Generally you hear, "Where are you?" Nowadays, we ask, "What is your location?" You describe the place in words. About your whereabout. In mathematics, we can tell the location in numbers. Depending on whether you are in a line or in the field, your location can be described in one number or in two numbers. Suppose you are standing in a queue and waiting for number to come. Your friend likes to join you and ask you, "Where are you?" You will simply tell him that you are at 5th place. It means it is just one number, which is good enough to describe your location. Now suppose you are standing on a ground where some performance is going on the stage. You tell your friend that you are just 10 meters from the stage. Your friend will find it difficult to locate you. He goes to the stage and scan the direction where you are standing. Had you also told him the direction with respect to a point on the stage, he would have found you. It means you tell your location in two parameters, the distance and the directions. Let's suppose you are traveling in a plane and your seat is 24F. You will simply follow and reach 24th row and look for F in A, B, C, D numbering of the seat. It is noticed that we need two numbers to know a place. If you are roaming in a city, you will keep a city's map to keep you informed that where you are, you follow certain well-known key place of the city to refer yourself for your location. You may use a map available online or digital map on Google platform such as Google Map, which also provide your location that you can share. Note: this map tells you the location of UEN Joses in Paris as 48.75 and 2.14 in latitude and longitude. Latitude and longitude is a coordinate system which is used to determine the position or location of a place on the Earth's surface. We have two hemispheres, north and south, divided by an imaginary line, the equator. The latitude is measured in degrees, from 0 to 90 degrees, from equator to south, or North Pole, using imaginary center of the Earth. It is divided from 0 to 90 from equator to North Pole and South Pole. The longitude is measured in degrees, from 0 to plus minus 180 degrees, east or west, from our imaginary line, prime meridian, from North Pole to South Pole, passing through Greenwich, London, UK. Greenwich Observatory has latitude 51 degrees 28 minutes 38 seconds and longitude 0 degrees 00 minutes 0 seconds. Similarly, to locate the position of a point on a plane, we require a coordinated plane with pair of perpendicular coordinated axes and a reference point. That could be the origin, 0, 0, where two axes intersect on the coordinated plane. Let's recap. A dot or a point. A point is the most fundamental object in the geometry. A dot has a 0 size, that is, 0 length, 0 width, and 0 height. A point is defined by its location or a place in a space. Coordinate of a point. As a point is defined by its location, we may express its place in space in terms of a number or numbers, so that some calculation or mathematical manipulation can be done. The line. A line is a collection of infinite points that extends on both the sides, indefinitely in a plane. Movement of the point traces a line. A straight line could be horizontal, vertical, or tilted. And a line could be curved, with or without any regularity or similarity. coordinate of a point. The simplest coordinate system in one dimension is a line system, where all points lie on a line. In this system, the line is coordinated, and an arbitrary point is chosen as origin. The line system, where an arbitrary point is chosen on a given line, considered as origin. The coordinate of a point is defined as a distance of point from origin O in a positive or negative direction. Here, for example, P is 11 and N is negative 12. You know, we have 4 directions: north, south, east and west, to refer the location of a place. In mathematics, in geometry in particular, 2 perpendicular lines in a plane are chosen as axis x and axis y. The point of intersection of these 2 perpendicular lines is considered as a reference point, or the origin with coordinates as 0, 0. With reference to the origin 0, 0, the distance on x-axis or on y-axis is given sign of positive or negative. X-axis on the right of origin is positive and left is negative. For y-axis, top of origin is positive and below the origin it is negative. A French mathematician, René Descartes, 1596–1650, who first developed the idea of using an ordered pair of coordinates x, y to specify a point in a plane relative to a pair of intersecting lines. To honor René Descartes and recognizing his work on this x-y axis system, it is known now as Cartesian coordinated system. In mathematics, it is an analytic geometry, and it is also known as coordinate geometry. The coordinate geometry we cover here is also known as Cartesian geometry. It is the study of geometry using Cartesian coordinated system. Graph papers. Coordinated paper or grid paper is a writing paper that is printed with fine lines, making up a fine regular grid. The lines are often used as guide for plotting a graph of a function or experimental data and drawing a curve. In classroom or on a desk, it is preferred to use pre-printed graph sheet. To summarize, to locate the position of a point on a plane, we require a pair of coordinate axes. The distance of a point from the y-axis is called its x-coordinate, or abscissa. The distance of a point from the x-axis is called its y-coordinate, or ordinate. The coordinates of a point on the x-axis are of the form x, 0, and that of a point on the y-axis are of the form 0, y. Note here, point A has coordinates 20, 25. X-coordinate of pointer is 20. It means it is 20 unit away from y-axis. Y-coordinate of point A is 25. It means it is 25 unit away from x-axis. Let us place following points on a graph paper: A, 10, 20, B, 18, 24, C, -16, 20, D, -10, -20, and E, 20, -20. First mark X and Y axes, and scale the grid as per requirements. Note there are 4 quadrants for positive and negative coordinates. In first quadrant, both x and y are positive. In second quadrant, x is negative and y is positive. In third quadrant, both x and y are negative. In fourth quadrant, x is positive and y is negative. Please understand what is 10, 20, and how to mark it. A, x, y is a coordinates of point A, where x equals 10, y equals 20. Its x-coordinate tells the distance of the point from the y-axis, that is 10. And its y-coordinate gives the distance of the point from the x-axis, that is 20. Another common system to locate a point from a reference point or from an origin is to know its distance and its direction. This coordinate system in a plane is the polar coordinate system. An arbitrary point is chosen as pole or origin. An array from this point is taken as polar axis. For a given angle theta, there is a single line through the pole. The angle theta is measured counterclockwise from x-axis to the line. Then there is unique point P on this line, whose distance from the pole or the origin is r. Therefore, the pair of coordinate of this point in polar coordinate system is r theta. Note, the coordinate of the pole is 0 theta for any value of theta. Note, this is how graph format of the polar coordinate system looks like. It is coordinated in distances, an angle of direction 0 to 90 in all for quadrant. Compare graph format of the polar coordinate system and Cartesian coordinate system. Two coordinates of the polar system, r, theta, can be converted to the Cartesian system, x, y, as follows. X equals r cos theta, and y equals r sin theta. Also, tan theta equals y divided by x. R equals square root of x squared plus y squared. Let's recap. The triangle. A triangle is a closed-shaped figure with 3 angles, 3 sides, and 3 vertices. When one angle in a triangle is 90 degrees, it is a right-angled triangle. Right-angled triangle. Pythagoras theorem. Pythagoras theorem states, in a right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other 2 sides. A squared plus b squared equals c squared. Remembering trigonometrical ratios, sine, cosine and tangent. Sin A equals opposite divided by hypotenuse. Cos A equals adjacent divided by hypotenuse. Tan A equals opposite divided by adjacent. Back to the coordinate geometry. We now work on distance of a point. A point A is at 15, 20. A, x, y is a coordinates of point A, where x equals 15, y equals 20. What is the distance of A from origin to O? We remove the grid for clarity, and drop perpendiculars on x-axis and y-axis. AOC is a right-angled triangle. Apply Pythagoras theorem to determine OA. We know AC equals 20 and OC equals 15. AO squared equals OC squared plus AC squared equals 20 squared plus 15 squared equals 400 plus 225 equals 625. Therefore AO equals 25. Distance between 2 points. A point A is at 25, 0. And point B is 8, 0. Place point on the graph. Note both the points are on the x-axis as their y-coordinates are 0. Distance between the points is difference of two x-coordinates. That is x1 minus x2. Or 25 minus 8 is equal to 17. Distance between 2 points. A point C is at 0, 25. And point D is 0, 12. Place point on the graph. Note both the points are on the y-axis, as their x-coordinates are 0. Distance between the points is difference of two y-coordinates. That is y1 minus y2. Or 25 minus 12 is equal to 13. Distance between 2 points. A point P is at 20, 25. And point R is 8, 10. Place point on the graph. Note both the points are in first quadrant and positive. Join P and R by a line. Drop perpendiculars from P and R on the x and y axis. And one perpendicular from R to the perpendicular line from P to x-axis. PQR is a right-angled triangle. Apply Pythagoras theorem to determine PR. First, we determine PQ and RQ. Length of PQ is 25 minus 10 is equal to 15. Length of RQ is 20 minus 8 is equal to 12. Apply Pythagoras theorem. PR squared equals PQ squared plus RQ squared. Calculating we get. Therefore PR equals 19.209. Distance formula. Between points. To get the general formula of distance between 2 points. Let point P is at x1, y1, and point R is at x2, y2. Follow the same steps as we did just now, and we will get the formula. It is important to note that x, y are variable, and the coordinates for a general point. But x and y with suffix x1, y1 represent a fixed point of coordinates x1 and y1. Follow the steps and apply Pythagoras' theorem to determine PR. Therefore PR equals square root x1 minus x2 whole squared plus y1 minus y2 whole squared. Next we work out the midpoints. Letter point A is at 18, 24. Find the midpoint between point A, 18, 24, and origin, 0, 0. Let the midpoint M is at x, y. If length of line OA is d, then the length of line OM equals 1/2 d. Draw perpendiculars from the point A and M on the x-axis, intersecting at B and C. Note triangles OAB and OMC are similar. Right-angled triangle. Therefore AB by MC equals OB by OC equals OA by OM. 24 divided by Y equals 18 divided by X equals D divided by 1/2 D equals 2. Therefore Y equals 12. Therefore X equals 9. The midpoint between point A, 18, 24, and origin, 0, 0, is M, 9, 12. Find the midpoint between 2 points A, 18, 24, and B, 6, 8. Let the midpoint is at M, X, Y. If length of line BA is D, then the length of line BM 1/2 D. Draw perpendiculars from the point A, B and M on the x-axis, intersecting at F, E and D. Draw a line BC parallel to x-axis. Note: AC equals AD minus CD equals 16. BC equals FD equals OD minus OF equals 12 and MG equals Y minus 8. BG sad smiley X minus 6. Triangles ABC and BMG are similar right-angled triangle. AC by MG equals BC by BG equals BA by BM. AC by MG equals BC by BG equals BA by BM. 16 divided by Y minus 8 equals 12 divided by X minus 6 equals D divided by 1/2 D equals 2. 16 divided by Y minus 8 equals 2. Therefore, Y equals 16. And 12 divided by X minus 6 equals 2. Therefore X equals 12. The midpoint between point A, 18, 24, and B, 6, 8, is M, 12, 16. Find the midpoint formula between 2 points A, x1, y1, and B, x2, y2. Follow the same steps. Let the midpoint is at M, X, Y. If length of line BA is D, then the length of line BM 1/2 D. Draw perpendiculars from the point A, B and M on the x-axis, intersecting at F, E, and D. Draw a line BC parallel to x-axis. Note: AC equals y1 minus y2, BC equals x1 minus x2, and MG equals y minus y2, BG equals x minus x2. Triangles ABC and BMG are similar right-angled triangle. AC by MG equals BC by BG equals BA by BM. y1 minus y2 divide by y minus y2 equals x1 minus x2 divide by x minus x2 equals d divide by 1/2 d equals 2. Therefore y equals 1/2 of y1 plus y2, and x equals 1/2 of x1 plus x2. The midpoint between point A, x1, y1, and B, x2, y2, is m, x1 plus x2, whole divided by 2, y1 plus y2, whole divided by 2. The slope at point A is at 15, 20. It is visibly clear that point A is elevated from origin O. Angle of elevation is theta. What is the slope, or gradient of the point A from origin O? We define the slope of the point A from origin O as height over distance equals AC divided by OC, or equals tan theta. Therefore the slope of the point A from origin O equals 20 divided by 15. What is the slope of the point A, x1, y1, from B, x2, y2? We define the slope m of the point A from origin O as height over distance equals AC divided by BC, or equals tan theta. The slope m equals y1 minus y2 whole divided by x1 minus x2. The slope m equals y1 minus y2 whole divided by x1 minus x2. That's equals difference between y coordinates divided by difference of x coordinates. It is important to keep order of coordinates and sign intact to get correct slope with correct sign. The locus of a point is the path of the point traces as it moves, obeying a rule. So everywhere on the path the point must obey the same rule. All the points on the line passing through the point B, x2, y2, and the point A, x1, y1 will have same slope. This is one of the examples where a point has same slope from B to A. The Loci, plural of the locus is Loci. Best example of a locus of a point is the circle where a point moves so that it is always at same distance from a fixed point O. Note here, in the animation, how a point at a fixed distance moves. Locus, circle. Point coordinates x, y are such that the distance r square, x square, plus y square, if the fixed point is origin, 0, 0. This is circle equation of radius r and center at origin. Another example of a locus of a point is that it is at a same distance a from a line or x-axis. It can be written in formula as y equals a. Note, a locus of a point at a same distance b from y-axis. It can be written in formula as x equals b. Another example. Rule: equal distance from two fixed points, A and B. The locus of a point is the perpendicular bisector of the line joining A and B, that is OC, where all points are at same distance from A and B. Rule: equal distance from two intersecting lines or perpendicular lines. To find locus of the point, we choose x-axis and y-axis as two perpendicular lines. 2 points A and B are at equal distance x. We get Loci are two angled bisectors of the angle between two lines. The locus of a point is the bisector of the angle between the lines at the point of intersection O. That is the either line joining O and A. or O and B, as line OA is the angle bisector. All the points will be at equal distance from both the lines or axes. It means both the coordinates of the point are equal, or y equals x. Another line will be OB as also a bisector, where y equals minus x. Rule: equal distance from a line and a point. Let line is parallel to y-axis and point on x-axis. Using equal distance rule. For a point A, x, y, which at equal distance from line x equals A, and from a fixed point, which is called center or focus, the locus will forms a parabola with equation y square equals 4 times ax. The line locus of a point is a line under certain rule. Line could be a straight line. Also, a line could be a curved under some condition, as we saw in case of a circle and parabola. Any line can be written in terms of an algebraic equation. Geometric line in algebra. A straight line can be written in terms of algebraic equation, so it's called a linear equation. Straight line in a plane is represented in algebra by two-variable first-order equation, ax+by+c equals 0. Note: A and B are coefficients, c is constant, and x and y are variable. We will explore the line now. Line ax plus by plus c equals 0. To confirm, we draw a line on a graph paper. Let S take a simple equation. 2x plus y plus 3 is equal to 0. We bring out some points from this equation. We rewrite the equation as y equals minus 2x minus 3. For x equals 1, y equals minus 5. For x equals 4, y equals minus 11. Line 2x plus y plus 3 is equal to 0. We draw a line 2x plus y plus 3 is equal to 0 on a graph paper with points 1, minus 5, 4, minus 11, 7, minus 17, and 10, minus 23. Remember, only 2 points are sufficient to define a line or line segment. 7, minus 17, and 10, minus 23. Straight line. We generally refer a line that means a straight line. A straight line can be defined by 3 ways. Number 1. By an equation. Linear algebraic equation of 2 variables. Number 2. By 2 points in space. Number 3. By 1 point and its slope. General equation of a straight line. ax plus by plus c equals 0. A straight line is defined by a linear algebraic equation of two variables, x and y. Note: x and y are referred as the coordinate of a point on the line. A and b are coefficient and c is constant in the equation. Slope of straight line. As defined earlier, the slope of the line is change in y coordinate with respect to change in x coordinate, or m equals tan theta equals delta y divided by delta x between 2 points A, 1, minus 5, and B, 10, minus 23. Delta y equals 10 minus 1 is equal to 9. Delta x equals minus 18. Therefore m equals tan theta equals minus half. Please note, the slope of the line moving in first and third quadrant is positive. The slope of the line moving in second and fourth quadrant is negative. The slope of the line parallel to x-axis is 0 and parallel to y-axis is infinity. Slope equation of a straight line. Please note, other than a general linear equation, the line's equation can also be written in following forms: the slope. Number 1. Slope-intercept form. Number 2. Point-slope form. Slope-intercept form is most common. Slope-intercept form is y equals mx plus c, where m is the slope of the line, and c is an interceptor of line on y-axis. Let the line intersect on y-axis at point P, where x-coordinate of the P is 0. Putting x equals 0 in the equation y equals mx plus c, we get y equals c. Therefore the point P is an interceptor of line on y-axis and OP equals c. Please note, the line equation ax plus by plus c equals 0 can be written in slope-intercept form. Ax plus by plus c equals 0 can be rewritten as by changing sides. By equals minus ax minus c, or y equals minus a divided by b times x minus c divided by b. On comparing, y equals mx plus c, m equals minus a divided by b, and c equals minus c divided by b. For example, in 2x plus y plus 3 is equal to 0. Slope m equals minus 2, and c equals minus 3. Slope-intercept equation of parallel lines. Advantage of defining A line in this form y equals mx plus c helps in getting parallel line, as slopes of all parallel line is same. Parallel lines are y equals mx plus c1, y equals mx plus c2, y equals mx plus c3, and so on. Slope-intercept equation of perpendicular lines. The slope of two perpendicular lines are of opposite sign and inverted. The product of slopes of two lines should be m1 times m2 equals -1, or m2 equals -1 divided by m1. Perpendicular lines of y equals mx plus c are y equals -1 divided by mx plus c2, and so on. Slope equation of lines parallel to x-axis. Line parallel to x-axis are y equals d. Comparing it with y equals mx plus c, no x variable is found, as m equals 0. Slope equation of lines parallel to y-axis. Line parallel to y-axis are where x equals f. Comparing it with y equals mx plus c, no y variable is found. It is only possible when m is infinity, as we know tan 90 is infinity. Point slope form equation of line. Point slope form equation of a line of slope m passes through a point A, B. A point on the line, x, y, will have a slope of m equals y minus b divided by x minus a, or y minus b equals m times x minus a, or y equals mx plus b minus ma, is the equation of the line of slope m and passing a, b. Point slope form equation of a line of slope 3/4 passes through a point A, 10, 15. A point on the line, x, y, will have a slope of 3 divided by 4 equals y minus 15 divided by x minus 10, or y minus 15 is equal to 3 by 4 times x minus 10. So the equation is 3x minus 4y plus 30 equals 0. Two points form equation of line. A line passes through the points A, 10, 15, and B, 30, 30. First find the slope of A and B. msad smiley 30 minus 15, whole divided by 30 minus 10, equals 15 divided by 20 equals 3/4. Line equation y equals 3/4 x plus c. To get the value of c, we put coordinate of 1 point, 30, 30. So 30 equals 3 or 4 times 30 plus c. Or c equals 30 minus 3/4 times 30. Equals 30 divided by 4. Putting the value of c, we get the equation as 3x minus 4y plus 30 is equal to 0. A line passes through the points A, x1, y1, and B, x2, y2. Take a point P at x, y. Find the slope of P and A. M equals y minus y1 whole divided by x minus x1. From a point P at x, y. Find the slope of B. M equals y minus y2 whole divided by x minus x2. Both slopes are same. M equals y minus y2 whole divided by x minus x2 equals y minus y1 whole divided by x minus x1. Y minus y1 whole divided by x minus x1 equals y minus y2 whole divided by x minus x2. Is general form of the equation of the line passing through 2 points, x1, y1, and x2, y2. Intersecting. Straight lines. Two straight lines, if not parallel, will intersect each other at one point. The point of intersection is a point common to both the lines. The coordinates of the point of intersection will satisfy the equations of both the lines. To get the point of intersection of two lines given by two linear equation, we solve them simultaneously. Let one line is ax plus by plus c equals 0. Another is dx plus ey plus f equals 0, where a, b, d and e are coefficient and c and f are constants. Value of x and y, which satisfy both the equation, is the point of intersection. If the equation of lines are in slope-intercept form, it will be easier to solve. Let one line's equation is y equals m1x plus c1, and second is y equals m2x plus c2. We solve them as m1x plus c1 equals m2x plus c2, or x sad smiley c2 minus c1 whole divided by m1 minus m2. By putting the value of x in any one of the line's equations, we get coordinate y. Let's explore two lines' equations. 3x plus 6y equals 18 and 2x minus y plus 3 is equal to 0. Draw these lines from point. 2 points for line number 1. Point A, x equals 10, y equals minus 2. And B, x equals 30, y equals minus 12. 2 points for line number 2. Point C x equals 5, y equals 13. And dx equals 10, y equals 23. Solving two equations. 3x plus 6y equals 18, and 2x minus y plus 3 is equal to 0. We get x equals 0 and y equals 3. This can be confirmed by the graph of the lines. Rewrite two equations in slope-intercept form. 3x plus 6y equals 18, or y is equal to minus 3 divided by 6x plus 3. Or y equals minus 1/2 x plus 3. And 2x minus y plus 3 is equal to 0, or y equals 2x plus 3. Comparing above equations with y equals mx plus c, it is found c equals 3. In both the equations, confirming that both the equations are intersecting at the intercept point on y-axis. Comparing two equations. In slope-intercept form, y equals minus 1/2 x plus 3 and y equals 2x plus 3. With y equals mx plus c, it is found the slope of first equals minus 1/2 and the slope of second is 2. The product of these two slopes is minus 1. Hence must intersect at 90 degrees. Note it on the graph. Distance of a point from a line. The distance of a point to the line is the length of the perpendicular from the point to the line. Let the point x1, y1, and equations is y equals mx plus c. The equation of the perpendicular PD will be y minus y1 equals minus 1 divided by m times x minus x1. Find the intersecting point P of two lines by solving equations. Y equals mx plus c and y minus y1 equals minus 1 divided by m times x minus x1. The distance between point x1, y1, and line y equals mx plus c is distance between the point x1, y1, and point of intersections x2, y2. Using the distance formula, we get the lengths of the perpendicular. For example, find the distance of point D, 10, 23. And from line AB x plus 2y equals 6. Rewrite in slope-intercept form. Y equals minus half times x plus 3. Line slope, m equals minus half. The perpendicular line slope m equals 2. Passing from point D, 10, 23. Y minus 23 is equal to 2 times x minus 10. Or y equals 2x plus 3. By solving equations, we get the intersecting point of two lines as 0, 3. Using the distance formula, AB equals square root x1 minus x2 whole squared plus 1 minus y2 whole squared. The distance from D, 10, 23, and P, 0, 3, is calculated. dP equals square root 100 plus 400 equals 22.36. Let us recap some basics. Concept of the area. A closed shape. Figure. On a piece of paper. Draw a figure with the help of a line or combination of lines, starting from a point and ending at the same point. It is a closed-shaped figure which covers certain space, which is known as its area. Area of the closed-shaped figure is the amount of space it covers in a plane. It can be measured with the help of its two dimensions, length and breadth. Note: to calculate the area, sometimes it is important to know perimeter of the figure, which is the length of the total boundary lines that encloses the figure. A quadrilateral. A quadrilateral is a closed-shaped figure in a plane with four sides, for angles and for vertices. The square. It is a very simple quadrilateral, where all four sides and all four angles are equal. Both the diagonals are equal and perpendicular. Area of a square equals square of the side equals AB square equals a square. In term of the diagonal D, area of the square T equals 1/2 times D square. The rectangle. It is a quadrilateral, where both the opposite sides are equal and parallel, and all four angles are equal and right angles. In a rectangle there are two dimensions, its length a and its breadth b. Area of a rectangle equals length times breadth equals a times b. Or in other words, area of a rectangle equals base times height equals a times b. The trapezium. It is a quadrilateral, where only two of its opposite sides are parallel. In a trapezium, only two of its opposite sides are parallel. Let its parallel sides are A and B. Area of a trapezium can simply be worked out as T equals 1/2 times A plus B times H, where H is the height or distance between two parallel lines. Area of a figure, or polygons, when the coordinates of vertices are known. It is better first we draw it on a graph paper to visualize it. With the help of coordinates, we calculate the required sides of the figure to calculate the area using certain formulae. Area of a square. We start with a simple figure, a square, made by, for straight lines, the coordinates of all vertices of a quadrilateral, or a polygon, are known. Case number 1. When a side of a square is parallel to an axis, vertices are x1, y1, x2, y1, x2, y2, and x1, y2. Note on the graph, the sides are parallel to both x and y axis. The side of the square is the difference of the coordinate of any two vertex, either x2 minus x1 or y1 minus y2. Area of the square equals AB2 equals x2 minus x1 whole squared. We take an example and calculate the area. The coordinates of vertices of a square are 4, 4, 4, 24, 24, 24, 24, 4. Follow the steps to understand. Area of the square equals AC squared equals 20 square equals 400. Area of a square made by for straight lines. The coordinates of all vertices of a square are known. Case number 2. When a side of a square is not parallel to any axis, vertices are x1, y1, x2, y2, x3, y3, and x4, y4. Use distance formula to calculate any one of sides of a square. Distance formula is AB equals square root x1 minus x2 whole squared plus y1 minus y2 whole squared. Area of the square equals AB square equals x1 minus x2 whole squared plus y1 minus y2 whole squared. We take another example to calculate the area of a square when the coordinates of vertices of a square are 3, 15, 15, 24, 24, 12, 12, 3. Watch the steps. Area of the square equals AB squared equals 225. Area of a rectangle. We take another simple figure of a rectangle made by 4 perpendicular straight lines. The coordinates of all vertices are known. Case number 1. When a side is parallel to an axis, vertices are x1, y1, x2, y1, x2, y2, and x1, y2. Note on the graph, the sides are parallel to both x and y axis. The side of the rectangle is the difference of the coordinate of any two vertices. Side AB is x2 minus x1, and AC is y2 minus y1. Area of the rectangles equals length times breadth equals AB times AC equals x2 minus x1 times y2 minus y1. To calculate the area of a rectangle, we take an example. Vertices are 5, 5, 5, 24, 20, 5, 20, 24. Now follow the steps. Area of the rectangle equals AB times AC equals 15 times 19 is equal to 285. Area of a rectangle. Case number 2. When a side of a rectangle is not parallel to any axis, vertices are x1, y1, x2, y2, x3, y3, and x4, y4. Use distance formula to calculate the of sides length and breadth of the rectangle. Using distance formula, AB equals square root x1 minus x2 whole squared plus y1 minus y2 whole squared. AC equals square root x1 minus x3 whole squared plus y1 minus y3 whole squared. Area of the rectangle equals AB times AC equals square root x1 minus x2 whole squared plus y1 minus y2 whole squared times square root x1 minus x3 whole squared plus y1 minus y3 whole squared. Take an example. Vertices are 3, 13, 17, 26, 28, 16, 14, 2, and calculate the area. Area of the rectangle is equal to 14.9 times 19.1 equals 284.6. Area of a trapezium when the coordinates of vertices of a trapezium are known. Case number 1. When its parallel side is parallel to an axis. Vertex are x1, y1, x2, y1, x2, y3, and x1, y2. As side are parallel to both x and y axis. To calculate the area of the trapezium, we need to know AC, BD, and CD. The sides are the difference of coordinates of two vertex. AC equals A equals y2 minus y1. BD equals B equals y3 minus y1. And CD equals H equals x2 minus x1. Area of a trapezium. T equals 1/2 times A plus B times H. Or T equals 1/2 times y2 minus y1 plus y3 minus y1 times x2 minus x1. To calculate the area of a trapezium, we take an example. When vertices are at 5, 5, 5, 24, 20, 5, 20, 20. Now watch the steps.
Area of a trapezium. T equals 1/2 times a plus b times h. T equals 1/2 times 19 plus 15 times 15 equals 255. Let us recap. Area of the triangles. Area of a triangle. Area of a triangle equals 1/2 times base times height. Remember that any side of a triangle may be taken a base, then the corresponding height would be the perpendicular distance from the base to the opposite vertex. In right-angled triangle, the base and the height are clearly defined. The height and the base are perpendicular and may be interchanged while calculating the area of the triangle. The result would be the same. Area of a triangle. Heron's formula. Area T equals square root s times s minus a times s minus b times s minus c. Note: A, B and C are the length of sides of the triangle, and S is semiperimeter. S equals 1/2 times a plus b plus c. Area of a triangle. From the coordinates of its vertices A, x1, y1, B, x2, y2, and C, x3, y3. Area of a triangle. Using Heron's formula, area T equals square root s times s minus a times s minus b times s minus c. Side AB is C, side BC is A, and side AC is B. From triangles vertices A, x1, y1, B, x2, y2,
and C, x3, y3. The sides can be calculated using distance formula. AB equals square root x1 minus x2, whole squared plus y1 minus y2, whole squared. AB equals C equals square root x1 minus x2, whole squared plus y1 minus y2, whole squared. AC equals B equals square root x1 minus x3, whole squared plus y1 minus y3, whole squared. BC equals A equals square root x2 minus x3, whole squared plus y2 minus y3, whole squared. Note semiperimeter S equals 1/2 times A plus B plus C. Apply now Heron's formula for area T. For application of Heron's formula, area T equals square root S times S minus A times S minus B times S minus C. We take an example of a triangle whose vertices are A, 9, 27, B, 26, 10, and C, 5, 5. Sides AB, BC, and AC are calculated using distance formula as follows. Please note the steps. Now side AC. Now side CB. Now calculate semiperimeter S. If we do calculations accurately, without any approximations, we get the area of the triangle as 221. Area of a triangle equals 1/2 times base times height. In case a side of the triangle is parallel to an axis, the above formula is very useful and convenient. Note in the figure, side CB of the triangle is parallel to x-axis. We apply the formula equals 1/2 times base times height. Let side CB is the base equals x2 minus x3, as y coordinate is same for B and C. Point D of perpendicular AD is x1, y2, and perpendicular AD equals y1 minus y2. Area of the triangle equals 1/2 times base times height equals 1/2 times x2 minus x3 times y1 minus y2. In another triangle ABC, side AC of the triangle is parallel to y-axis. We may choose AC as the base equals y1 minus y3. Point D of perpendicular AD is x1, y2, and perpendicular BD equals x2 minus x1. Area of the triangle equals 1/2 times base times height equals 1/2 times y1 minus y3 times x2 minus x1. We take an example of a triangle whose vertices are A, 9, 27, B, 26, 10, and C, 9, 5. Follow the steps to get the area of the triangle. You may pause the video to calculate yourself. Using indirect method. Area of a triangle. From coordinates of its vertices. A, x1, y1, B, x2, y2. And C, x3, y3. Indirect method are. Number 1. Using area of a trapezium. Number 2. Box method. Using area of a rectangle and area of right angle triangle. Indirect method using area of a trapezium. Vertices of a triangle are A, x1, y1, B, x2, y2, and C, x3, y3. Drop perpendiculars from A, B, and C to the x-axis at D, E, and F. Note: 3 trapeziums are formed: ADF-C, ABED, and CBEF. Note: 3 trapeziums are formed. Area of the triangle ABC equals area of ADFC plus area of ABED minus the area of CBFE. Note on the graph. Animated area of the triangle ABC. Area of a trapezium ADFC equals 1/2 AD plus CF times FD equals 1/2 Y1 plus Y3 times X1 minus X3. Area of a trapezium ABED equals 1/2 AD plus B times Z equals 1/2 Y1 plus Y2 times X2 minus X1. Area of a trapezium CBEF equals 1/2 CF plus BE times EF equals 1/2 Y3 plus Y2 times X2 minus X3. Area of the triangle ABC equals area of a trapezium ADFC plus area of a trapezium ABED minus area of a trapezium CBFE. Area of ABC equals 1/2 Y1 plus Y3 times X1 minus X3 plus 1/2 Y1 plus Y2 times X2 minus X1 minus 1/2 Y3 plus Y2 times X2 minus X3. Solving and rearranging, we get area of ABC equals 1/2 times bracket X1 times Y2 minus Y3 plus X2 times Y3 minus Y1 plus X3 times Y1 minus Y2, bracket closed. To explain further, we take an example of a triangle whose vertices are A, 9, 27, B, 26, 10, and C, 5, 5. Follow the steps to get the area of the triangle. You may pause the video to calculate yourself. Area of ABC equals 221. Earlier, by Heron's method, area of same ABC was also equals 221. The calculation involved in Heron's method were tedious and lengthy. The Heron method is good when all sides of the triangle are known. When coordinates of vertices are known, this method is better. Area by box method. Area by box method. This is an indirect method. We enclose the figure of a polygon in a tight horizontal box where vertices are touching the box. In this method, we calculate the area of a polygon using simple calculations of the area of a rectangle and right-angled triangles. Note a quadrilateral here. Note a 5-side polygon here. The area of triangle by box method. This indirect method use area of a rectangle, an area of right-angled triangle. Let the vertices of a triangle are A, x1, y1, B, x2, y2, and C, x3, y3. Let the coordinates of a triangle are A, x1, y1, B, x2, y2, and C, x3, y3. Now, form a rectangle CDEF by lines parallel to x-axis and y-axis which passes through the vertices of the triangle A, B, C. Note: this rectangle's vertices are C, x3, y3, D, x2, y3, E, x2, y1, and F, x3, y1. Area of the triangle ABC equals area of the rectangle CDEF minus the area of right-angled triangle ACF minus the area of right-angled triangle AEB minus the area of right-angled triangle BCD. We have an animated area of the triangle on the graph. Area of the rectangle CDEF equals CF times CD equals y1 minus y3 times x2 minus x3. The area of right-angled triangle ACF equals 1/2 CF times AF equals 1/2 times y1 minus y3 times x3 minus x1. The area of AEB equals 1/2 EB times EA equals 1/2 times y1 minus y2 times x2 minus x1. The area of BCD equals 1/2 BD times CD equals 1/2 times y2 minus y3 times x2 minus x3. Area of the triangle ABC equals area of the rectangle CDEF minus the area of right-angled triangle ACF minus the area of right-angled triangle AEB minus the area of right-angled triangle BCD. Solving and rearranging, we get same formula as earlier. Area of ABC equals 1/2 x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Box method is an indirect method of getting the area of the figure using the simple calculations of the area of a rectangle and the area of right-angled triangles. To explain further, we take an example of a triangle whose vertices are A, 9, 27, B, 26, 10, and C, 5, 5. Vertices are A, 9, 27, B, 26, 10, and C, 5, 5. Form a rectangle CDEF by lines parallel to x-axis and y-axis, which passes through the vertices of the triangle A, B, C. Note: rectangle's vertices are C, 5, 5, D, 26, 5, E, 26, 27, and F, 5, 27. Area of the triangle ABC equals area of the rectangle CDEF minus the area of right-angled triangle ACF minus the area of right-angled triangle AEB minus the area of right-angled triangle BCD. Watch animated area of the triangle. Area of rectangle CDEF equals CF times CD equals 27 minus 5 times 26 minus 5 equals for 62. Area of ACF equals 1/2 CF times AF equals 1/2 27 minus 5 times 9 minus 5 equals 44. Area of AEB equals 1/2 EB times EA equals 1/2 27 minus 10 times 26 minus 9 equals 144.5. Area of BCD equals 1/2 BD times CD equals 52.5. Area of the triangle ABC equals area of the rectangle CDEF minus the area of right-angled triangle ACF minus the area of right-angled triangle AEB minus the area of right-angled triangle BCD. Area of the triangle ABC equals 462 minus 44 minus 144.5 minus 52.5 is equal to 221. Earlier, by Heron's method and trapezium method, area of same ABC was also equals 221. Area by box method. Some typical, practical, solved examples are explained. When not all vertices of a triangle are touching the box. To explain further, we take an example of a triangle whose vertices are A, 10, 20, B, 25, 25, and C, 5, 5. Draw the triangle ABC, and later make a box. In this case, we get one right-angled triangle BCD and one odd quadrilateral ABEC, as point A was not touching the box. To solve further, and to make easier, draw lines parallel to X axis and Y axis from A to lines EC and EB. Now we have, within quadrilateral ABEC, one rectangle AGEF, and two more right-angled triangles BGA and ACF. Area of the triangle ABC equals area of rectangle CDBE minus area of rectangle AGEF minus area of right-angled triangle BCD minus area of right-angled triangle ABG minus area of right-angled triangle ACF. Area of the triangle ABC equals area of rectangle CDBE equals CD times BD equals 25 minus 5 times 25 minus 5 equals 400 minus the area of rectangle AGEF equals EF times AF equals 25 minus the area of triangle BCD equals 1/2 BC times CD equals 1/2 25 minus 5 times 25 minus 5 equals 200. Minus the area of triangle ABG equals 1/2 AG times BG equals 1/2 25 minus 10 times 25 minus 20 equals 37.5. Minus the area of triangle ACF equals 1/2 CF times AF equals 37.5. Area of the triangle ABC equals 400 minus 25 minus 200 minus 37.5 minus 37.5 equals 100. Area by box method. Some cases of polygon solved examples. Area of a square by box method. The coordinates of vertices of a square are 3, 15, 15, 24, 24, 12, 12, 3. Note: the sides are not parallel to the axis, so apply here box method. To get the area, try making a box to enclose the square ABCD. Note the coordinates of E, F, G, H. Area of the square ABCD equals area of rectangle EFGH minus area of right-angled triangle ABE minus area of right-angled triangle BCF minus area of right-angled triangle CDG minus area of right-angled triangle ADH. Watch animated area of the square. Area of the square ABCD equals area of rectangle EFGH equals GF times GH equals 24 minus 3 times 24 minus 3 equals 441. Minus area of right-angled triangle ABE equals 1/2 AE times BE equals 1/2 times 24 minus 15 times 24 minus 12 equals 54. Minus area of right-angled triangle BCF equals 1/2 BF times CF equals 54. Minus area of right-angled triangle CDG equals 1/2 GC times GD equals 54. Minus area of right-angled triangle ADH equals 1/2 DH times AH equals 1/2 times 24 minus 15 times 15 minus 3 equals 54. The area of the square equals 441 minus 54 minus 54 minus 54 minus 54 is equal to 225. Area of a rectangle by box method. The coordinates of vertices of the rectangle are 3, 13, 17, 26, 28, 15, 14, 2. Note: the sides are not parallel to the axis, so apply here box method. To get the area, try making a box to enclose the rectangle ABCD. Area of the rectangle ABCD equals area of rectangle EFGH minus area of triangle ABE minus area of triangle BCF minus area of triangle CDG minus area of triangle ADH. Area of rectangle EFGH equals GF times GH equals 28 minus 3 times 26 minus 2 equals 600. Area of right angle triangle ABE equals 1/2 AE times BE equals 1/2 times 28 minus 17 times 26 minus 15 equals 60.5. Area of right angle triangle BCF equals 1/2 BF times CF equals 91. Area of right angle triangle CDG equals 1/2 times GC times GD equals 60.5. Area of right angle triangle ADH equals 1/2 times DH times AH equals 91. Therefore area of the rectangle ABCD equals 600 minus 60.5 minus 91 minus 60.5 minus 91 equals 297. By this method, area of any quadrilateral can be found. Area of a pentagon by box method. The coordinates of vertices of the pentagon are 3, 13, 17, 26, 28, 15, 20, 2, 10, 2. We will apply here box method to get the area. Try making a box to enclose the pentagon ABCDE. Area of the pentagon ABCDE equals area of rectangle FGHK minus area of right angle triangle ABK minus area right angle triangle BCF minus area right angle triangle EDG minus area of right angle triangle AEH. Area of rectangle KFGH equals GF times GH equals 28 minus 3 times 26 minus 2 equals 600. Area of right angle triangle ABK equals 1/2 AK times BK equals 60.5. Area of right angle triangle BCF equals 1/2 BF times CF equals 52. Area of right angle triangle EDG equals 1/2 times GE times GD equals 38.5. Area of right angle triangle AEH equals 1/2 times EH times AH equals 91. Therefore area of the pentagon ABCDE equals 600 minus 60.5 minus 52 minus 38.5 minus 91 is equal to 358. By this method, area of any polygon can be found. We thank you for watching this video. You may subscribe this channel to watch more and more videos uploaded earlier. Do not hesitate to send your suggestion. Thank a lot.